This final project is where everything comes together. You'll secure a realistic AI agent workflow, test the controls, document governance evidence, assess residual risk, and make a deployment recommendation an enterprise reviewer could act on. So far, you've built the pieces of a secure AI agent workflow: risk identification, least privilege boundaries, prompt injection defenses, data leakage controls, human approval, monitoring, auditability, governance, and testing. Now the work shifts from learning each control separately to applying them as one system. Your final task is to secure an end-to-end agent and justify whether it is ready to deploy. This project is not about proving a single control works in isolation. It is about securing the full workflow: retrieval, external APIs, sensitive data, tool calls, and high-impact actions. Start with the threats in your model, then show which controls reduce each one, including access control, validation, logging, monitoring, and output filtering. Just as important, make your claims verifiable. Test results, logs, monitoring rules, and review artifacts should support your final recommendation. Deploy, delay, or restrict use based on residual risk, not just feature performance. Imagine a support operations agent working inside a real enterprise. It does not just chat. It retrieves policies, tickets, procedures, and customer records, then works across CRM, email, billing, ticketing, calendars, and cloud tools. That creates meaningful risk, because the workflow may expose sensitive data or trigger actions such as refunds, access resets, subscription changes, or data deletion. Your security design must therefore cover privacy, access control, audit logs, encryption, monitoring, and an approval gate before any high-impact action is executed. Before adding controls, document how the workflow actually behaves. Capture the major components: the interface, agent runtime, model, retrieval layer, tools, data stores, external APIs, logs, and approval service. Then mark the trust boundaries, because risk changes whenever information moves between users, model context, tools, systems, or human reviewers. Pay special attention to two paths: sensitive data and high-impact actions. Finally, show where policy enforcement, validation, logging, and monitoring occur. This turns security from a checklist into a traceable, risk-based design. A good threat model turns broad concerns into specific risk decisions. Start by naming the assets that matter, such as documents, credentials, user data, permissions, logs, and operations. Then identify who or what could threaten them, including malicious users, compromised integrations, insiders, poisoned content, and outside attackers. For each actor, map realistic attack paths: prompt injection, exfiltration, privilege abuse, unsafe tool calls, approval bypass, or missing logs. The key is linkage. Every serious threat should connect to at least one preventive, detective, or corrective control, plus a clear view of residual risk. A permission map makes tool access explicit. The agent should receive only the operations required for its task, not broad access because it is convenient. Separate read-only actions from write, administrative, and destructive actions because each carries a different level of risk. For conditional access, constrain inputs with schemas, allow lists, scoped credentials, and context rules. Also document what is denied, such as deletion, sensitive exports, or policy bypasses, and when escalation is required. This makes least privilege auditable, enforceable, and easier to review. Prompt injection occurs when untrusted content tries to act like instructions. A document says, "Ignore previous rules." A tool response says, "Send secrets." A user asks the agent to bypass policy. The defense is instruction hierarchy. System and developer rules remain authoritative. User requests are handled within those limits. Retrieved documents, web pages, and API responses are treated as data to analyze, not commands to obey. A secure agent should refuse override attempts, protect secrets, restrict tool use, and be tested against direct, indirect, and multi-step injection chains. Data exfiltration control means looking at every path data could take out of the system. Begin by classifying what is sensitive, such as identity, financial, health, confidential, or secret data. Then define what the agent may retrieve, summarize, transform, or disclose. Every outbound action needs gates, policy checks, output filtering, redaction, and destination allow lists. That includes visible responses and less obvious routes like tool arguments, webhooks, file exports, or external APIs. Strong testing should cover direct requests, indirect prompts, encoded leakage, and cross-tool handoffs. The goal is simple: authorized use only, with sensitive data protected. High-impact actions need a clear gate between recommendation and execution. First, define what counts as high impact: external emails, refunds, permission changes, deletions, or infrastructure changes. Then set review triggers, such as risk score, sensitive data, user role, or transaction value. When the gate is reached, the reviewer should see the full case: the proposed action, the model's rationale, affected systems, data involved, and rollback options. The decision is approved, rejected, or modified, and the details are logged before execution for auditability. A production AI system needs evidence for every important step: the user request, model decision, retrieved sources, tool calls, policy checks, approvals, and final output. Structure matters. Instead of vague text like tool failed, record searchable fields such as trace ID, user ID, tool name, policy result, risk score, approval status, and redaction applied. That makes reviews faster and investigations more reliable. Logs also need security controls. Hash or tokenize sensitive identifiers, omit secrets, restrict access, and prevent tampering. Correlation IDs connect separate events into one end-to-end story, which is exactly what auditors and responders need. Monitoring is where agent security becomes operational. Policies and approvals only help if failures create visible signals. Strong programs alert on repeated policy violations, blocked tool calls, failed approvals, suspicious retrieval, unusual data volume, unexpected destinations, high-risk tools, and prompt injection patterns. Each alert needs more than a threshold. It needs severity, an accountable owner, investigation steps, and a response timeline. Track metrics like mean time to detect, mean time to respond, false positives, and control effectiveness. The goal is not noise. It is fast, reliable detection that improves operations. A security plan is credible only when it is tested like a real system, not reviewed like a checklist. Build cases for prompt injection, data exfiltration, tool misuse, approval bypass, privilege escalation, and logging gaps. Include normal workflows that should succeed, as well as adversarial workflows that should be blocked or contained. For each test, capture the input, expected control behavior, actual result, evidence, owner, and status. When something fails, fix it, retest it, and keep the remaining risks visible. That evidence is what proves the controls work. The governance package turns the technical build into an accountable deployment decision. Include the threat model, permission map, checklist, test results, incident considerations, residual risk summary, and recommendation. The key is traceability. If risk remains, explain the business impact, likelihood, compensating controls, and named owner. Then recommend deploy. Deploy with conditions or do not deploy. That recommendation should follow the evidence, not optimism or personal confidence. Finally, get sign-off from the functions that will live with the decision: security, product, legal or compliance, and operations. Securing AI agents is not a one-time checklist. It is a life cycle. Model threats, design layered controls, implement carefully, test with evidence, monitor operations, review ownership, and improve continuously. Your final project should show clear links between threats, controls, validation, and residual risk. Next, complete your submission, present your review package, and apply this method in production.